Hello, welcome back to Chapter 9, Section 7, where we're solving quadratic equations using square roots. Now, when I first introduced this in the previous video, I talked about the radical sign, the square root sign. There are other radical signs, but you can ignore that for a moment. But we talked about the square root sign being the inverse of squaring something, okay, which means to the second power. And I also mentioned it was kind of like, adding and subtracting are inverses of each other, multiplying or dividing. Well, now we're going to see all of that in these problems. We're going to see the entire thing. And I'm going to put something over here so that you remember this. The order of operations. So if I have a bunch of numbers that are supposed to do things together, there are parts of them multiplied, added, subtracted, exponents, whatever. The order that I do these exponents we call PERMDAS with an R. Adding and subtracting are inverses of each other. So if I add 5, like this one, to get it backwards, I'm going to subtract 5. And 5 plus negative 5 equals 0, which is important. We actually say, and I've been doing this if you've been catching it, we actually say subtraction doesn't exist, or I do. I don't know if anyone else does, because subtraction really means adding the opposite of what you're subtracting. And I will show you that with this one, and actually a little bit with that one too. Okay, just as not as obvious because I already got subtraction there. Multiplying and dividing go together. So if I'm going to multiply this by 4 to get that 4 to isolate the x, to get that 4 to get away from the x, I'm going to have to divide by 4. Well, there's really no such thing as division either. What I'm going to really do is multiply by the reciprocal of 4, which is 1/4. Finding 1/4 of 4 is the same as dividing by 4. If someone in your family, if your grandma or whoever makes a pan of brownies, I'm kind of hungry for brownies right now, and you get 1/4 of them, that's the same as dividing that pan by 4. So these things, they go together. These are inverses of each other. So it's important, this is why it gets frustrating for me for when teachers leave out the R. It's important that we understand that those two go together too. Exponents and radicals, or you can call them roots, both of them start with an R. Exponents and radicals, because like you saw with the previous problem, which I'll pull up that paper, to isolate the x and to get the, that's a bad one, to isolate the x and get the x all by itself, where I just have x, I have to take the square root when I have x to the second power. Those are inverses of each other. And yeah, it kind of implies if I have x to the third power, x to the fourth power, are there inverses of that? Yeah, there's cube roots and fourth roots. But anyway, you don't need to worry about that for right now. I'm going to solve this equation by working backwards and doing the inverse of whatever's happening. So probably should have spaced that over a little bit more, so I'm going to write it like this. 4x to the second power subtract 25 equals 0. Now what I like to do, and I've been doing this since I started teaching solving equations, is I draw a line which separates the left side from the right side. Some teachers don't like that because now I've drawn a line through the equal sign, which technically means not equal to, but that's not true. It's obvious that I'm dividing this into the left side and the right side. Whatever I do to one side, I need to do to the other side. If I look at the x squared in order, if I replace the x with a number, first I would take care of the exponent because the e comes first. Then I'd multiply by 4 because the m for multiplying comes next. And then I would subtract 25, so I have exponent, multiply, subtract in that order. I need to work backwards, so I'm going to do it in reverse PERMDAS order. So I'm going to start with the last thing I would have done would have been subtracting 25, so now I'm going to work backwards. I'm going to add 25 to both sides of my equation. This bar is just me like doing a total bar, okay? So 0 plus 25 equals 25, that's easy. Negative 25 plus 25, that equals 0. And 4x to the second power plus 0 just equals 4x to the second power. All right, cool. Now I'm multiplying by 4. The opposite of multiplying is dividing. So I'm going to divide both sides by 4. I do it with a fraction bar. I don't use the obolus. The obolus is this symbol right there. We're trying to avoid using the obolus in all the math that we ever do. It causes confusion and delay. Sorry, that was a old school reference. Unfortunately, I'm going to have to use it in my Algebra 2 class, in something they're going to be working on. But for now, we're not going to use it. We're going to use fractions. The 4 divided by 4 equals 1. When I multiply by 1, that leaves the x to the second power alone. 1 times anything doesn't change it. So 4 divided by 4 equals 1. And this is just times 1. Just like negative 25 plus 25 equals 0. And when I add 0, it doesn't change anything. Now you're probably going to want to divide 25 by 4 and get 6 1/4. Don't. How do I know that I shouldn't do that? Because on my sheet of perfect squares, 25 is a perfect square and 4 is a perfect square. That's a clue that I'm actually going to do this in a different way. So I'm going to leave it as a fraction, 25 divided by 4. It's okay, you can write it that way. Now I'm back to what I was doing in the previous video. I'm going to take the square root, and I should have given myself some space. I wasn't thinking. I'm going to squeeze that plus or minus right there. All right? It's still there, I just didn't give myself enough space. That's why you don't use markers, guys. On this side, I just get x. But this is what's cool. The square root of 25 is 5, and the square root of 4 is 2. So all I have to do is take the square root of the top, the numerator, take the square root of the denominator, and just leave it. And you're probably going to want to change that to I'm sorry, I got the hiccups. You're probably going to want to change that to 2.5. Don't. Just leave it 5/2 and negative 5/2. Don't forget that there are 2 solutions. Positive 5/2 and negative 5/2. There are 2. Okay, this one's a little bit more straightforward. Sometimes when I'm just straight up copying these from the examples from the book, sometimes I kind of question is why they're in the order that they are. It doesn't really matter. Okay, so I'm going to do the same thing. I got x squared plus 5 equals 5. I'm going to add negative 5 to both sides. That's the same as subtracting 5, but I'm adding negative 5. And I get x to the second power equals 0. Well, what does that mean? If I take the square root, don't forget I get 2 plus or minus. I get x equals plus or minus 0. Okay? That doesn't make sense. You can't have positive 0 or negative 0. So this is just an example where you get one answer, but you're actually getting the same thing twice. Okay? You get x equals 0 twice. All right, we're going to do more of these examples, but I'm going to save those for the guided practice problems later. We'll see you in the next video.